All right, so we are going to simplify rational expressions today. So each of these is a fraction that has polynomials in the top and the bottom. And the two basic steps, which I'm going to write right here between number 1 and number 2. Your step 1 is to factor everything, exclamation point. And then number 2, cancel top and bottom. So that's the two things that we need. So cancel things that are the same from the top and bottom. That'll make more sense when we get into it. I did not write you really technical directions, but once you see how this works, it won't be too bad. The big thing is remembering all the different factoring things that we've learned. They kind of all get thrown together, but we'll review as we go. So on number 1, I've got a couple of binomials. They have 2 terms on the top, 2 terms on the bottom, and so I want to look and see if there's common factors I can take out. So 50 and 30, I could take out a 10 and an x, and then I would be left with 5x minus 3. On the bottom, I have 30 and 30, so I can take out a 30, and I can also take out an x, and then I'm left with x minus 1. So we've rewritten this fraction in a form where it's factored, completely factored. There's nothing else I can take out of either sets of parentheses. So we factored everything. Now we're going to see if there's anything that we can cancel. Automatically, I see this x and this x that are not attached to anything else, and I can cancel those. You cannot cancel the x's over here that are in the parentheses. If you do that, a kitten will die. Okay? Like, you cannot cancel x's that are over here because they're part of a group. They're attached to this, they're subtracted from that, they're in a group. The only way I could cancel these is if those groups were exactly the same. I knew I'd get your attention with a kitten. Or you can change that to a puppy, which is ever more dramatic for you.
I would do it.
Okay. So what about the 10 and the 30? Could we do anything with that?
Take a 10 out.
Take a 10 out. So we can make this a 1 and this a 3. And so when you get done, you rewrite it. The 1 is not super important to have there because I'm going to take 1 times this. You could actually just leave it as 5x minus 3. And then in the bottom, we can write it as 3 and then x minus 1. I started to put the parentheses there. You can leave the parentheses on the 5x minus 3 or not. Basically, I just knew it was multiplied by 1, so it's not a huge deal. The fraction bar still groups this as a group with or without the parentheses. Also optional, you could distribute the 3 back out and make this 3x minus 3. I am not going to make you do that. It's not like that on the answer key for today's assignment. So basically, we're just trying to get this in a form where we've gotten rid of as much stuff as possible. All right, so that's number 1. Let's take a look at number 2. So this has 3 terms. It's a quadratic trinomial on both the top and the bottom. And those are the ones that we factor using our x puzzles. So on the top, we multiply to get negative 10 and add to get 3. So we need 2 numbers that multiply to make negative 10, add to make 3. What do you think?
5 and 2.
5 and 2. So it'd be positive 5 and negative 2, and that works. So on the top, I'm going to have 2 sets of parentheses, x plus 5 and x minus 2. And then we can do the same thing with the bottom. We're going to multiply to make negative 6 and add to make 1, which would be the coefficient of that p. So what multiplies to make negative 6 that adds up to 1?
Negative 2 and 3.
Negative 2 and 3. So we can have, I'm going to put it this way, x plus 3 and x minus 2, just to line this up. So if I have these 2 groups here that are the same, I can cancel that out. I can get rid of the x minus 2's. And then I only have 1 group on the top and bottom, so if I feel so inclined, I can get rid of the parentheses because the fraction bar keeps them separate, the top and the bottom. The parentheses just keep like the different factors separate when you have more than 1. Okay? If you like keeping the parentheses on the answer, it doesn't hurt anything. Just so you guys know. All right? So lots and lots of factoring. Let's take a look at number 3. So this has the same basic setup. We've got the quadratic trinomial. There's no coefficients in front of those v squareds. So we're just going to factor both of them this way. So we're going to multiply to make negative 21 and add to make negative 4.
Negative 7 and 3.
Got negative 7 and 3. So I'm going to have x minus 7 and x plus 3. And then we're going to multiply to make 7 and add to make negative
So
8.
can we do x's instead of like
Negative
v's
7
or
and
p's
-1.
or?
Oh, no, I was supposed to write v's. That's a good question. No, you should keep the same letters. I accidentally changed it to
Oh,
x's.
that's fine.
Probably because I made x's here and my brain
Mhm.
works that way. I meant to write v's. So what multiplies to make 7 and adds to make negative 8?
Negative 7 and negative 1.
Negative 7 and negative 1. So let me write the v's this time. V minus 7 and v minus 1. So the v minus 7s can cancel, and we can write it as v plus 3 over v minus 1. And that one is done. Okay. Let's take a look at number 4. The top of number 4 is a difference of squares. And if you know the shortcut for that, you know that the formula for a difference of squares is a squared minus b squared equals a plus b and a minus b. So we're thinking of this as being k squared minus 4 squared, and you can use that shortcut and do k plus 4 and k minus 4. Now, if that doesn't work for you and you can't remember that, you can also pretend that middle, or not pretend, just say, okay, the middle term is 0, and you could actually use the x, say, okay, it multiplies to make negative 16 and adds to make 0.
4 and negative 4.
And you would still come up with negative 4 and positive 4. So you can think of it either way. Both work. And then the bottom has the 3 terms, and so we can go ahead and just use this method. So we're looking for 2 numbers that multiply to make 24 that add up to negative 10.
6 and 4.
So negative 6 and negative 4 will work. So on the bottom of my fraction, or I'm sorry, yeah, that's right. Okay. So we'll have k minus 6 and k minus 4. And the k minus 4s can cross out. Just to make sure you guys understand, if there's a k minus 4 on the bottom and a k plus 4 on the top, those are considered different. They have to be exactly the same. So our final answer would be k plus 4 over k minus 6, and I like taking the
Would you
parentheses
reduce it?
off. You cannot reduce the k's. That's when puppies die, or kittens, or horses, or whatever you're attached to. So because it was part, this is all considered a factor. And even though I took the parentheses off, it's still considered this is a factor and this is a factor. This is a polynomial that's tied together with a plus sign and one with a minus sign. We can only cancel things out that are separated from other things by multiplication. Okay? Puppies and kittens. So that's what you need to remember. If I cancel these out and they were part of a group, something dies.
I'll tell my college professor that.
I know, they will probably look at you funny, but yeah, that's how I was taught, so that's how I remember. It's a little morbid. All right, so let's do the next one. So on the top, we're multiplying to make negative 45. On the bottom, negative 4,
Negative 9 and 5.
negative 9 and 5. You guys are so fast. So x minus 9, x plus 5, and then the next one, we're multiplying to make negative 40 and adding to make negative 3. So negative 8 and 5. I beat you. Okay, it's okay. So x minus 8 and x plus 5. So the x plus 5s can cancel. We get x minus 9 over x minus 8. All right, so those kind of all looked the same. Here towards the bottom, I'm going to have some twists. We're exactly halfway through this. So if we look at number 6, what could I do with the top? It's not a difference of squares because I don't have v squared, and 3 is not a square.
Yeah.
I can take a 3 out, take out that greatest common factor. So I can take a 3 out, make it v minus 3. Good job. The bottom is the quadratic trinomial with a leading coefficient of 1. So that's where we use the x. So we're looking for numbers that multiply to make negative 24 that add up to 5. So that would be 8 and negative 3. So I'd have x plus 8 and v plus 8 and v minus 3. And so the v minus 3's cancel, and you'll just have 3 on the top and v plus 8 on the bottom.
Okay.
And we can take the parentheses off. If you still had more than one factor on the top or the bottom, you'd leave the parentheses to separate them or distribute it out. But since we left it pretty simple, we can take it all off. Okay, so now for another twist. So 7, what could I do with the top?
3.
Could take out a 3 again, and I'd have x minus 7. Now, we have a little issue with the bottom. I'm going to do something kind of weird. First, I'm going to take this, I'm going to turn it around so the x's are in the front, because we want it to look as much like the top as possible. I'm going to make it negative 6x plus 42. And then I'm going to take out a negative 6, which would give me x minus 7. So turn it around and put the x on the front, and then take out the negative with the number, and that makes this easy. So the x minus 7's cancel, and I have 3 divided by negative 6, which is negative 1/2. And we just got like a regular number for the answer, but it happens sometimes. Don't freak out if it happens. I always kind of liked it. It was like, oh, I got rid of all the variables. There we have a number.
Simple.
Simple. Okay, so let's take a look at 8. What can we do with the top?
2.
Take out 2.
Take out a 2, and then we have b plus 2 in there, and then the bottom we'll use the x. So multiplies to make negative 18, adds to make negative 7,
So negative 9 and 2.
negative 9, and positive 2. So b minus 9 and b plus 2. So the b plus 2's will cancel, and we'll just get 2 over b minus 9. Okay. So 9 and 10 have a little bit more to them. On 9, you'll notice that they've got the x squared after the x, and that's usually a case where you want to turn that around. So just up here, I'm going to rewrite it. Negative 3x squared plus 24, and then I can take it over here and turn that out. So I want to take that negative out. I'm going to take out the negative 3. Oh, yes, negative 24x. So I'm going to take out a negative 3 and an x, and that'll leave us with x minus 8. And then down here, I notice I have a third power, and there's x's in all terms. So let's take out a 2 and an x first. So I'd have 2x and then x squared minus 4x minus 32. And then, so the 2x will sit out in front, but we can factor the rest of this further. So we can look for numbers that multiply to make negative 32, that add up to negative 4.
Negative 8 and 4.
So negative 8 and 4, and so I'll have x minus 8 and x plus 4. So more possibilities for canceling here. We can cancel the x minus 8s, and you can cancel the x's because they are separate. They're not part of a group here. And then we just write down what's left. So we've got negative 3 still in the top, and we've got 2, and we've got x plus 4 on the bottom. And if it bothers you to still have those parentheses, you could distribute and put 2x plus 8 if you wanted to. What if everything in the top canceled? What would you do?
Put 1.
Put a 1, yes. So that's a good question. It doesn't show up in any of these examples. I should have had at least one of those. But just so you know, if everything cancels, you would need to still have a 1 in the top. In the bottom, not so much. You could just get rid of the bottom of the fraction. But if it happens in the top, just like with normal fractions, you'd still want to have a 1 up there. So if that comes up, you'll know what to do. All right, so the top of number 10 is just one of those easy trinomials. Multiplies to make 4, adds to make 5, so it'll be 4 and 1. So we'll have x plus 4 and x plus 1. On the bottom, I see that third power and x's in all the terms, so I'm going to see what all we can take out. We can take out an x, and what else can we take out? A 3. So we'll take out a 3 and an x, and that'll leave me with x squared plus 9x plus 8 in the parentheses. So I can factor that further, looking for numbers that multiply to make 8, that add to make 9.
So 8.
So 8 and 1. So over here, we'll still have that 3x. Don't forget to copy that over. And then we'll have x plus 8 and x plus 1. So I can cancel the x plus 1s. And that's pretty much it. Everything else is going to have to stay. So I'll keep the x plus 4 in the top. I'll keep the 3x and the x plus 8 in the bottom. And that is it.